The topic that we are going to cover is about frictional forces and viscous drag. Now, when a solid slides against another solid, it develops a sliding friction. However, a rotating wheels a rotating wheel will experience a rolling friction. Rolling friction, if other conditions are controlled, then rolling friction is less than the sliding friction. Now here the important thing is that on what factors the rolling friction and the sliding friction depends on. But before that, you must know that if something is sliding against another surface, then the friction acts against the slide. If you push it forward, then the friction acts on backward. If you push an object forward, then the friction will act on the object in the backward direction. And one thing should be clear, friction is a variable force. As you increase your push or the resultant force, as you increase your push or the forward force, the friction also increases until it reaches its maximum value called limiting friction. There is a limit for limiting friction between every two surfaces which are sliding against each other. So if you increase your forward push, the friction will go on to increase, and when it reaches its maximum value, then after that, if you increase the push further, it is the time when the motion will start, and once the motion is started, then friction will remain constant. It cannot change further. So once the forward push exceeds the once the forward force push exceeds the limiting friction, then the once the forward push exceeds the limiting friction, then the motion will start. So once you get a situation when the forward push exceeds the limiting friction, it is the time then when you will get the motion. Now, if we plot a graph between friction on the y-axis and push or the applied force on the x-axis, then the shape of the graph would be, you get a point which is called limit of friction or maximum friction or limiting friction. It is a maximum value of friction. Now, when you increase the push, the friction will also increase. A time will come when the friction becomes constant. And here the friction is called limiting friction or the maximum friction. Before that, in this region, there is no motion. As long the push is less than the limiting friction, you will not achieve any motion. So you need to know that, and when the push will be greater than the limiting friction, the motion will start. And once the motion is started, the friction remains constant. The solid friction remains constant. So you should know that as long the push, pull, or the forward force, as long the applied force, forward force, push or pull, as long the forward force is less than the limiting friction, as long the forward force is less than the limiting friction, no motion. As long the push or the forward force is less than the limiting friction, no motion at all. When the push or the forward force gets bigger than the maximum value of the friction called limiting friction, then the motion will start and the friction will remain constant. Same principles apply to rolling friction. For example, if a wheel is rotating, then for rotating wheels, the rules for friction are same, yet the friction is called the rolling friction. And the direction of the rolling friction is a bit, it's a concern to be understood. For example, if you have a rotating wheel, first of all, you see It's the only one point of the rotating wheel that touches the ground. Ground is tangent to the wheel. If the wheel is moving in this direction, then rotation of the wheel would be clockwise. A clockwise rotation of the wheel will result in the forward motion. Yet the interesting factor is that friction here will stop this rotation. And as a result, if this point P in the rotation, it is moving backward. So point P is rotating backward when the wheel is moving forward. So friction on point P will be in the direction of motion. Yet it is opposing the rotation, so its net effect is against the motion. So you must understand that for a rotating wheel, the friction for a rotating wheel, the friction is in the direction of the motion. However, it is opposing, the rotation, and hence motion. So when a wheel is rotating, the friction, instead of being against the motion, it goes in the direction of motion. Yet its net effect is against the motion, it is opposing the motion. And very important thing is that if you have a vehicle, and it is moving in the forward direction, then if you want to draw friction on the wheels, for example, for this motion of the vehicle on the road, if you want to represent friction on the wheels, then friction on the wheels is interestingly in the direction of motion. The wheels are rotating in this direction, for example, clockwise. When the vehicle is moving forward, the wheels are rotating clockwise, and this friction is opposing this rotation. The friction goes in the forward direction. However, on the two wheels, the friction could be same or different, yet we can call it as FR1 and FR2. In the vehicle, we have 4 wheels in total. If we want to represent friction on the vehicle instead of friction on the wheels, so for friction, overall friction on the vehicle, a vehicle has 4 wheels. These are the 4 wheels. It's moving forward, and the net effect of the friction is obviously against the motion. So it would be friction due to first wheel, less friction due to second wheel, less friction due to third wheel, less friction due to fourth wheel. So friction of all the wheels is acting against the motion. It will be added up to work against the motion. Now, what factors factors on which sliding or rolling friction depends. Before writing the actual factors, we need to remove the misconceptions first. There are two common factors or two common misconceptions which are to be cleared here. The first misconception that people have: increasing the speed has no effect at all, has no effect on the sliding or the rolling friction. So whether the car is driven slow or it's driven fast, its solid or sliding or wheel friction will be same. However, a student can ask that when I drive fast, sometimes the tires got damaged or they wear out or they burn out. What is the reason for that? So I should clear that work is forced into displacement. So when something is moving faster, its displacement will be more and work will be more as well, because of which the friction, the power will increase. Friction remains same. So at all the speeds, low speeds or high speeds, the friction is a constant. It cannot be changed. So that effect of heating or overheating or like burning out in the tires is generated because of the high speed that results in more displacement in a given time and hence more power or work, because of which more energy is converted to heat. Frictional work converts energy into heat, and if the speed is more, frictional work will be more and energy will be converted to heat at a faster rate. So this is the first misconception. Second misconception is about surface area. Increasing or decreasing the surface area has increasing the surface area has no effect on the friction. So increasing the surface area or decreasing the surface area has no effect on the friction. Friction depends on friction in solids, that is rolling friction, and sliding friction depends on the first factor on which friction depends is the normal contact force, that is generally, so normal contact force that is generally dependent on the weight. That's why the objects with heavy weight are difficult to move. They will have a high value of normal contact force and hence a higher value of friction. This is the fact. And the second factor on which sliding or rolling friction depends on is the roughness of the surfaces being in contact. Although friction is independent of the area of the surface being in contact, yet it is dependent on the roughness of the surface, that is called coefficient of the friction. So coefficient of the friction, or the constant that we use in friction questions, it represents the roughness of the surfaces, while the normal contact force represents the weight. That's why heavier objects experience more friction and are difficult to move. So today we have to cover here on. In the next class, we'll start from here and we'll cover the friction in fluids. So we have to cover up to this point in this slide, and it's about frictions in solid. In the next slide, we'll cover the friction in fluids. Take care, students. Khuda Hafiz.